I'm fascinated by this push to deep space exploration, and in particular your plans, and I want you to tell us a little bit about this, of lassoing an asteroid and pulling it closer to
Yeah,
Earth
yeah,
so we can examine it. What's the benefit and what's the probability?
yeah. Everybody uses the term lasso. The way we're going to get the asteroid has not been definitively determined yet, but sort of lassoing, catching it in a
Hmm.
capture device is one method. An alternative method is to go to a big asteroid, one that we don't want to change its trajectory passing by Earth, but we would like to take a giant boulder off of it
Hmm.
and take that and put it into a retrograde orbit, stable orbit of the moon. When we started this, when the president challenged us to put humans on an asteroid in 2025, I have to say NASA, like everybody, thought of what does he mean? And we all thought right away, okay, we need to fly humans to the asteroid belt, which is between Mars and Saturn or Mars and Jupiter. We need to fly astronauts all the way out there and put them on an asteroid. That that's one way to do it.
Hmm.
Highly unlikely, highly impractical, because that would mean we're bypassing Mars, which is already difficult enough to get to do an even more difficult mission. So why would you do that first and then come back to Mars? So we were also challenged to identify as many as possible of the Earth-threatening asteroids. We've identified about 98% of those that statistically we think could threaten Earth in the next 100, 200 years. We are very short of identifying a significant number of those in the smaller category, like 140 meters
Hmm.
and below. Those will still do a lot of damage to Earth. They can destroy communities. Some of them are city killers, not civilization killers like the big ones. But what we want, and the question now it comes to me more and more often in public for is, can we protect the planet? Well, today we can't. Today we have identified and characterized a lot of asteroids, but we need to develop the technology that will enable us to deter an asteroid from striking Earth. So this mission will fulfill a number of objectives. If we choose to go and try to capture the asteroid, and over time, and when I say over time, I don't mean like a day or two or a week or two, over a year, year and a half, because it's going to take us about a year, year and a half to reach this incoming asteroid. And we want one purposely that is on its way toward Earth, that
Hmm.
either the analysis says will impact Earth or will come close enough that it will get our attention. We want to try to rendezvous with that type of asteroid, put ourselves one in the same with it, whether we encapsulate it or get a boulder off of it. And then over the next year, year and a half, as it continues to fly toward Earth, just gently nudge it using solar electric propulsion, just thrust
Hmm.
against it. The average person who likes football or basketball or any sport knows that if somebody's trying to get to your shooter or to your quarterback, sometimes you may be smaller than the person coming in
Hmm.
to kill your quarterback. But if you just put your body in front of
Hmm.
them and try to get a little leverage and move them ever so slightly, they miss the quarterback by feet, that's like a mile. And that's what we want to do. We want to thrust against an asteroid for about a year, year and a half. And if we can change its course by a fraction of a degree and get it to move more toward the moon than Earth, at some point the moon's gravity will exceed that of the sun, because asteroids are kept in orbit by the gravity of the sun, not anything else. They orbit the sun either in big elliptical orbits, the ones that come in and worry us, or in big circular orbits, the ones that we don't even worry about because they're in the main asteroid belt and they'll never get anywhere close to us because they're never coming inside Mars. So we want one that's in a big elliptical orbit coming toward Earth that we can get with, push on for about a year, year and a half, cause its orbit to be perturbed just enough that the moon's gravity, as it gets closer, says, okay, come here, overrides the sun and draws it into lunar orbit. There are stable lunar orbits where it'll stay for 100 years. That gives us the opportunity to use our heavy lift launch vehicle and the Orion, send a crew there where we know how to go. Not easy, none of the stuff is easy, but we can much easier get a crew to the moon, to
Hmm.
lunar orbit, than we can out to the main asteroid belt. They would then practice some of the procedures that we would need when we get to Mars, because out there we aren't under the influence of Earth's gravity. We know how to operate in low Earth orbit because the dominant gravity is Earth's. We know about orbital mechanics. We know about all this stuff that a lot of great aeronautical minds have taught us through the centuries. We don't know how to operate when you get out around a moon of Mars, for example. We don't really know how does the gravity of that moon versus Mars's gravity versus the sun's gravity versus Earth's gravity? Because you're starting to talk about multi-planet impacts on you. So we've got to learn, how do we operate in this strange environment? How do we do proximity ops? How do we rendezvous with something out there? And then, how do we put astronauts outside to do a spacewalk? We know how to do it from the space station because there's microgravity, essentially no gravity. So we've learned how to operate. Tether yourself, just don't let it go, and you'll float around and you can do stuff. What about on the moon? The moon has gravity, not as much as Earth, but still, the moon's gravity is going to keep you there. Mars has gravity, less than Earth's also, so we think we know how we want to operate there. An asteroid is almost no gravity, but it is a very, very minor gravity. So if we can get used to having crews operate around an asteroid where they're either developing techniques to mine or to take samples, which we intend to do, and bring them back to Earth, we're learning a lot about going on to Mars. So we call it a proving ground. We've got Earth-centric things that we're doing today in low Earth orbit. We want to move out to Mars-centered. But in the middle, we've got to have a proving ground. 8 months away is too far.
Yeah.
2 years away, 2 days away, like it is to the moon and lunar orbit, that's okay. Something bad happens, at worst, we'll do like we did on Apollo 13. The moon's gravity will bring it in, throw it back out toward Earth, and the crew can come back. 8 months to Mars, something happens on the way, you're still going 8 more months.
Yeah.
And that's just halfway. That just gets you to Mars. So we've got to have, as I said again earlier, much more robust systems, and that's what we develop in the proving ground.
I just want to, before we close this segment, I just want to talk about how you're unlocking the mysteries of the universe, and in particular, the James Webb Space Telescope. Can you tell us a little about that?
I will try to tell you a little bit about it. I was privileged to fly on the crew that deployed the Hubble Space Telescope back in 1990, so I forget the math, but it's a long time ago. I think we're coming up on the 25th anniversary. Intended to be up there for 5 years. And as a result of developing techniques to do spacewalks, we rebuilt the Hubble Space Telescope on orbit such that it has 6 operating small observatories in it now, small telescopes that have revolutionized our textbooks and everything. James Webb is advertised to be about 100 times more powerful than Hubble. It operates in the infrared region for the most part, so it will enable us to look into the atmosphere of some of these 715 plus exoplanets that have been discovered through programs like Kepler, planets orbiting other suns. So when you talk about wanting to characterize other galaxies and other solar systems, James Webb is going to allow us to do that. Actually look into those atmospheres and say, okay, that one is not only an exoplanet, it's not only an Earth-like planet that's in what we call the habitable zone, just far enough from the sun not to be burned up, but not too far away such that life can be sustained on it. Some of those exoplanets may very well have life like us or some other form of life. We don't know that. But James Webb will enable us to look and get constituent measurements of the atmospheres of those planets to give us even better ideas about life on those planets. 2 questions we always ask ourselves, and we are constantly trying to find the answers. How did we get here?
Yeah.
How did this Earth form? What made the material that makes these mics and this paper and all this stuff? It didn't just happen, I don't think. But how did it happen? I'm a Big Bang guy. Did God open his hands or did God go like that? Exactly. I'm not really, I don't care how, but it happened. Yeah. And so what was the cause of the structure of the universe as we know it? And then the second question that we always ask is, are we alone? Yeah. We know we're here. And we know that if you believe in a supreme being as I do, that supreme being put life on this planet. But if it's as supreme as we think it is, would that thing or that person have just picked one out of 715 planets? If you only want to say the planets in the universe are only those that we've seen, which we know it's not. We know there are millions and billions of planets. Would that person have picked one out of 716 and said, that's the only one I'm going to put life on? I don't think so. I don't, personally. Yeah. So we're trying to answer that other question of, are we alone? Yeah. And that's what Curiosity is doing. That's what we hope to do by searching an asteroid, because asteroids they're just pieces of the puzzle about our own Earth. They all started, we believe, from the same point at some time in the life of this universe. And so asteroids now, we learn, some of them have tectonic activity, some of them have water, some of them have ice. They have all kinds of things. The more we learned about these other bodies in our universe, the more we'll understand about our own planet.